It's question 6, right? It's a functions question. It has a parabola in it. And this is what it says. It says S, which is -2 coordinate 0, and T are the x-intercepts of the graph of that equation. They're the x-intercept of F. And then it says here A is not a number equal to 0, obviously. Okay. So that's just something obvious there. Because if A was a 0, we would not be dealing with the quadratic equation, or a parabola rather. So they then say here R is the y-intercept of F and G. So they share that coordinate, which is this point here. So what we know is whatever D is, same as C. So then they say here the straight line R and T has the equation G is equal to something, something, something. So no, the straight line through R and T. So they are trying to emphasize 2 points that the graph passes through. Now, the first mark is out of 2. They're asking us to get the value of D, of which we said D is just the y-intercept of the straight line. So judging from the information we have on the straight line, we have the equation of the straight line. It may not be complete, but it at least has enough information to complete it if we do something. So you see, we have a coordinate that the line passes through here, and they're asking us to get D. What can we do to get D?
You see, it is things like that had me a bit like, okay, am I supposed to work at the derivative using like, yeah, was I supposed to do first derivative or second derivative? There's things like that. I just wanted to keep on checking, and I was trying to avoid that. I know you can use derivative.
Okay, so when you looked at this question, did you also check the memo to see what they did?
No, I don't like cheating.
No, wait. What do you mean by cheating? What are you going to do when you don't have the answer to your question?
Okay, true. Fair enough. Fair enough. Guess you can do so now.
Well, you don't have to
Okay.
check now because we're going through it. But you have to remember the memo is there for you to use. Only if you have a memo in the exam is it called cheating. But then you have a memo outside of the exam, because when you're stuck, that's the first line of defense. You see, your first line of defense is the memo, so that you go and see and you're like, oh yeah, that's all that needs to be done. Because for this question, the idea is you ask for D, right? D is a number in the equation. So in the equation, you can see
Oh,
that
this is mx plus c.
Yeah, if you're gonna solve for D, you can just throw in a y value that the graph passes through, and x value that the graph passes through, and then D will be the only thing missing, and then you can work out D, which is why this is a 2-mark question.
Oh, I meant I'm looking at the other D.
The other D.
Yeah, that one. I don't know why I pictured a D up there. That one.
Okay. Okay. Now I see. It's okay. It's okay.
That's what I said. Derivative. Yeah. Do you see?
Yeah. No, I get you. I get you. But anyways, so we see for 2 marks here, we can throw in a coordinate that the line passes through, of which that's why T is important, because now where Y is, we can put a 0. Where X is, we can put a 6. And then we can get a value for D, which is going to give us -12 plus D, which is a 0. And then -12 goes over to the other side. You have the D. So with that being said, D is a 12. So the Y value here is a 12. And us getting D, it has automatically got us the value of C. So that's why this is a 2-mark question. So fortunately, if you look at the next question, right, out of 4, we can already see that this is a 12 because it's just a y-intercept. It's not something we even have to work out. So if you're going to work out question number 6.2, the first thing to do is, let's see here, let's crop this. the first thing to do with getting 6.2 is to recognize the fact that we are supposed to just keep in mind that f of x, they
Mhm.
have not given us a value of a and b. Fine, that's what we should keep in mind, that a and b are the ones that are still left out.
Unknown. Yeah.
Start off right, we can say here c is equal to 12, and then here, if you want to maybe justify why you're saying c is equal to 12, you can just say y-intercept, you see, because it's something you have. So if you feel uncomfortable by just writing c is equal to 12, you can just mention that it's the y-intercept because you have it from 6.1. So when you get these kinds of things, just put it in your equation to see what you actually have left, and then you can take things from there. So now what you're seeing is you have two variables that you need to work out. So whenever you have two variables that you need to work out, your best bet is to sometimes use what you call uh simultaneous equation. But the idea is here you have two of your x-intercept 1, x-intercept number 2. So when you need to get the equation of a parabola, you can use the x-intercept. So what I can write out here is getting the equation of a parabola using the x-intercepts. So if you're going to get the equation of a parabola using the x-intercepts, this is how you do it. So the first thing you want to do is to keep in mind that any equation of a parabola, when it is factorized, it will look like this. Before you can end up with an equation that looks like this, right? The factorized version of that equation will always be something like this. Y is equal to a, and then x minus 1, and then x minus 2, like that. So the x1 and the x2 represent your x-intercepts. See, this here and this here, these are just your x-intercepts. Your value of a is the a value in your equation. Now, what you do is, remember, you want to end up with a trinomial, right? You want to end up with the quadratic equation. So what you can do is, this number you have, it's the first x-intercept. This number you have, it's the second x-intercept. The first x-intercept, we said it's a -2. This one is a 6. So where this is, you're going to throw a -2. Where this is, you're going to throw a 6. And then the x and the y. This is just the x coordinate and the y coordinate. So we have a coordinate that we can throw in there. X value is a 0, y value is a 12. So that's what we can do. Here, you can put a 0. Here, you can put a 0. Here, you can put a 12. And then you can see there's a number to put in for everything except for a. Now, since there's a number to put for everything except for a, that's a good thing, because we'll at least then be able to just work out whatever a is. So in practice, it's going to look like this. We're going to have here 12a, 0 minus -2, and then 0 minus 6. Now, 0 minus -2, this is going to be a negative and a negative, so it's a plus. 0 plus 2 is a 2, and then -6 here. And then 2 times -6 is a -12. And then here we're getting our a value as -1, which is quite reassuring, because in the equation that was supposed to end up with a here is a -1. So that's a good thing. Now, this is where things get easy. Once you have a value of a, you're home free, because in this equation here, you can now just put in a value of a, put in a value of x1, put in a value of x2, and then just multiply out the equation. you will end up with this equation up there. So let's do it. In the equation of f of x, we're saying where a is, we put a minus 1, and then it's here x minus negative 2, right? So that's going to be x plus 2. And then for the other one, there's a minus 6 here. So there's a 6 here, right? So it's x minus 6. And then with this equation, all we do is we just have to multiply out the bracket. So the minus 1, we can keep it out. X times x gives us x squared. X times negative 6 gives us negative 6x. 2 times x gives us 2x. 2 times negative 6 gives us negative 12. And then x squared, negative 6 plus this, right, gives us negative 4x. And then minus 12. And then this is f of x. So you can see that if you multiply inside, you're going to have negative x squared, and then positive 4x, and then positive 12, which is what they want us to end up with. You see, 4x there, positive 12 there, with a negative with a negative a at the beginning there. That's how you do 6.2. That's why it's just a formal question. So questions like these, right, they are just everywhere. We go through them. You practically go through them almost everywhere. If you, for example, look at, if I go to one of the papers that were recently done, like one of the prelim papers, as I mentioned, the prelims are papers that I'm going to. If you look at one of the prelim papers, I think it was even the Gauteng one, the Gauteng prelim paper, the one I recently did, or maybe even the Eastern Cape, whichever one of the prelim papers that I recently did. The question, one of the questions that's there is a question similar to the one we've just answered now. See, if I maybe, let's say, let me see here, f of x, this 6.1, 6 point what, no, this one already has the equation of the parabola, so it's not Eastern Cape. Let's check, I did what, Eastern Cape. I also did Northwest, so let's check the Northwest paper, maybe Northwest paper 1. This is one of the prelim papers that were also written, because remember, your prelim papers, the different prelim papers in the different provinces, they're not always very different from each other. They're usually actually quite similar in a way. So for example, here I'm looking for the parabola, what you call, for the parabola questions, but let's see here, positive, let's see, for x, da, 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 da. Let's see here, given the equation, this, given that f(x) equal to that, calculate that. Given that this is equal to that, write down the values of p and q. I think it was probably the Gauteng paper. Let's go to the Gauteng paper. Gauteng paper number 1. There it is. Let's see here. Let me open it up. Parabola question. Parabola question. Let's see what the parabola question looks like here. So if you look at this equation here, this is question 4 of the Gauteng paper 1, right? The prelim paper 2022. The question here, you can see they did not give us the equation of the parabola. So if you look at something like 4 point what, 4.3, 4.4, and let's see here, 4.5, 4.6, come on, 4.7. Let me see here. I did Gauteng and what was this? Gauteng, Eastern Cape, and what else was there? Gauteng, Eastern Cape, and K. Let me see. So question number 7. This is just financial math also. And then question number 8. 8 is more on calculus. Question number 9. 9 is also, yeah, so something like question number 9, right? You can see the resemblance is almost the same, in the sense that with the cubic function, unlike a parabola, with the cubic function, you're gonna have 3 brackets that will be representing your 3x intercepts. So you have 1, 2, and 3 brackets. And then in those 3 brackets, it's a matter of putting in your x intercepts. and then the number in front here will be your value of a. For example, you can see here, the value of a is automatically a -1. So that's why the factorized version of the equation, this number here is a -1. This is one of the x-intercepts, and then this is another x-intercept, and then this is another one. So because there's only two x-intercepts, the place where we have a turning point and an x-intercept, that's the place where the two brackets will look the same. So if there's a 6 here, you put a 6 over there and a 6 over there. And then this x-intercept is a 0. So that's why we put a 0 over there. So we put a 6 there, and we put a 0 there. And then the k we have, right, which is just going to be a -1 because of it's the value of a there. And then what we then did was we just multiplied out the equation, and then we multiplied out the brackets, and then we're ending up with the equation of the cubic function as requested. Now with other papers, right? It was actually I think with the calculus ones, that's the question that was actually almost like repeated often. What am I doing? Which one is this one? Those are the questions that were like repeated often. The questions asking you to get the equation of a cubic function. So my angle is I'm trying to say that when you get the equation of a cubic function, or when you get the equation of your parabola, the method is almost the same if you make use of things like your x-intercept. You see, so this one I think is just loading because I also wanted to show something from this question. But let's see here. Draw the graph of the cubic function, determine this. Let me see if there's any question here that asks us to get the equation of the cubic function. Write down the coordinates of this. No, not really. But anyways, it's fine. It's okay. So with our parabola here, that's what we just had to do. And this is something that you can do for different kinds of questions. You see, if you look at the format, you see, there's only two x-intercepts. That's why there's two brackets there. Cool.
Awesome. It just, yeah, like I said, I just kind of need to go through it.
So the memo also would, in most instances, be able to guide us and know where to go, so that we don't stay stagnant. Because the thing with memos is, yeah, they're meant to be used, so you need to use them heavy. So let me see. 6.3 is what we need to look at now. So 6.3, it's a 3-mark question. They're asking us to get the coordinates of the turning point. So what can we do to get the coordinates of the turning point?
The coordinates of the turning point. You see, the turning point. I want to say derivative, but no.
Yes, derivative. So because remember, with the turning point, it's a point where the gradient is 0, and your first derivative is a gradient equation. So all that terminology, right? It is like words that you want to know to place. So you can see now you mentioned derivative. You see, which is fine. The next thing would be to then know what does the derivative do, and to remember why your brain is thinking of derivative in the first place. So the reason your brain is thinking of the derivative is because your brain knows that the first derivative is an equation that can get you the turning point. That's what the first derivative is. The first derivative is an equation that can get you your turning point. So your turning point here, it's a point where your gradient will be equal to 0. So if you can get your gradient equation and make the gradient equal to 0, you will then be able to find out what the x value of the turning point is, of which, if you have the x value of the turning point, you can easily then get the y value of the turning point. using your equation, because in your equation of your graph, if you throw in an x value, it's just going to give you a y value. You see? So that's the idea behind the first derivative. Does that make sense?
Makes absolute sense.
Cool. So in the equation of our parabola, let's get the first derivative. The first derivative, I'm gonna say 2 times the -1, which is -2, and then we put the x. Removing 1 from the exponent, gonna get a 1. And then here, 1 times 4 is a 4. Removing 1 from the exponent, we're gonna get a 0. So x to the power of 0 is just a 1. So 4 times 1 is just 4. Differentiating a constant, it just falls away. So this is what we have as our first derivative. Now we said in our first derivative is a gradient equation. So in that gradient equation, we're making gradient as 0. And we're trying to find out what x value do we have at that gradient that is a 0. So here -2 goes over, becomes a plus. And then here you're going to divide by 2 on both sides. But that doesn't make any sense because this is, it means something is wrong, obviously. See? So you don't want to take that for granted, which is why you see there's the error. It's a +4. So this is a +4 there, +4 there, +2 over there. There we go.
I'm annoyed I've been making such mistakes as well. Well, I'm glad I'm making them now, but it's a little annoying.
No, you don't need to be annoyed by the inevitable. You just need to be aware of it. Like now, if the answer came out as a -2, you don't want to just take the answer and move on because you're seeing that the x is a +2. So you don't want to get frustrated and be like, what? Why am I getting a -2? You just want to check, okay, fine. The only reason there's a -2 there is maybe because there's a -4 here. So this -4 is coming from there, but then why is it a minus here when it's a plus there? Then you're like, oh, then it's just a sign error. You fix it there, you fix it here, you fix it there. You see?
I completely understand. I see.
So that's the x value. To get the y value now, we have to use the equation of the graph. Meaning in that equation of the graph where x is, we have to put it 2. So our y value where x is, we're going to put it 2. Put it 2 over there. Put it 12 over there. 2 squared is 4. And then 8 plus this is 20. 20 minus 4 is 60. And then you check. That kind of makes sense because if the y value here is a 12, it makes sense that up there we have a 16. Are we getting a 16? Yeah. So here we can say, therefore, turning point is just 2, 16. And then they'll give us those 3 marks as promised. Ooh.
That should be 4 marks, but yeah.
6.4 now. 6.4.1 rather out of 2.
You see, that's the type of stuff that I forgot heavy. See, there for 6.4, I was blank. I was like, wait. Am I supposed to equate it? Like put the two equations together, then make it. Basically, how is it in there? Is that what I'm supposed to do? But in the form of the equation. Does that make sense?
So with questions like these, right? The one thing you want to recognize is that the -g x, they're saying f of x minus g of x, where is it bigger or equal to 0? So the way you answer this kind of equation is you take the g of x to the other side so that you can see that the question can be answered like this. You see, this is asking, where are the y values of f bigger or equal to the y values of g? Now, these are the kinds of questions where, again, if you don't bump into them often enough, then they'll always just be questions you won't like. But remember, the responsibility of going through questions often enough, I don't know what you may want to think of that, because if you know that you don't maybe expose yourself to a lot of questions and expose yourself to a lot of memos, then I don't know what you want to do. See, because if you want to maybe say that you want to revise, fine, you can revise. But it just means you need to make you then need to make time for it. Of
Yeah.
which, if that the thing is, you wanna see that if you don't have enough time for something, right, you don't wanna fight against it. You just wanna then do what you can. Of which, what can be done now is this: expose yourself to as many memos as possible. And the one way to expose yourself to as many memos as possible is to go through as many papers as possible. So the papers are not there to just get you stuck. They are there to get you stuck, yes, but stuck, and then you look at the memo and you see how it's done. So in the memo, you'll see they'll probably have written something like this out, or something similar, or something else that you can use. So y values of f, where are they bigger or equal to the y values of g? So what you then need to recognize is these questions, the way you work them out is you go to where your graphs are equal first, you see, because they're asking where is the y values bigger or equal to each other. So they're equal to each other here specifically, they're equal to each other here specifically. So if you look at the nature of the question, determine the values of x. Determine for which values of x will this equation or will this inequality balance out. So we say the way you want to look at this inequality is f of x goes to the left, g of x goes to the right. The way you read the question, it just says where are the y values of f bigger than the y values of g. So you can see that they are, where are they bigger or equal to each other? So we can see it's easy to start with where they're equal. They're equal to each other where x is a 0, and they're equal to each other where x is a 6. You see. So now that we're looking at where x is a 6 and a 0, now we can ask ourselves, okay, fine, between looking at those points, right, or looking at that image, let's get an idea of where the y values of f are above the y values of g. So the graph of f is this parabola. So you can see here the y values of f, right, up here, they are above the y values of g, because you'll be tracing it for every x value. You see, so between 0 and 6, all these y values here are above all these y values of g. That's the only place where that's happening, because if you move to the left of 0 and if you move to the right of 6, that's not happening anymore, because after 6, the y values of f are lower than the y values of g. You see it?
I do see it.
To the left side, the y values of f are below the y values of g. You see it?
I see it.
Yeah. So the only place that qualifies for your answer is between 0 and 6. Between 0 and 6, that's the only place where the y values of f are bigger or equal to the y values of g. So when you write it out, you're just going to say the x values need to be bigger or equal to 0. The x values need to be smaller or equal to 6. And then that's going to give you 2 marks for this question. So the idea would be, the more often you bump into these questions, you then are able to make up your mind to say, fine, is this the kind of a question you can easily answer? If it still becomes a question that you always are not happy with, then you will know, okay, fine, we're just going to relegate this question, meaning in an exam, you won't even bother yourself, so that you save your time and you then come back to it later on when you know that your mark threshold or your mark target has been met, and you can go back to those kinds of questions. But you won't be able to know how to make that decision if you have not bumped into it often enough.
Okay, fair enough.
So with something like the next one, it is talking about x times f of x. Where is this expression a number that is smaller than 0? So again, we're gonna go through this fine. But the idea is this is not how you get it into your brain, or rather, it's gonna go into your brain. It's gonna make sense, but when you look at it on your own, it's gonna be a bit of a problem unless you go through it often enough. Going through it, seeing the memo, trying out, seeing the memo, trying out. So if you feel like that's not something that's within your capacity given the time, then over time you'll then just be able to say, okay, fine. These are the questions I only do last when I'm done with the paper. But anyways, it says determine the values of x. Determine for which values of x will this expression be smaller than 0. So the way you understand this is it's two things being multiplied together. Thing number 1 and then thing number 2. The question is, where will these two give you a number that is smaller than 0? Now the logic is the only way this will be smaller than 0 is if this is a plus while this is a minus. Or the only way this will be a negative is if this is a minus while is a plus. That's the only logic that will give us an answer that is smaller than 0. So what you then want to see now is, okay, fine. This is just talking about x values of our graph compared to its y values. That's all this is saying. It's x values of our graph being compared to y values of our graph. So when you're looking at the picture, the idea here is to just compare where you have positive or negative x values and where you have positive or negative y values. So color makes the word go round. So what you do kinds of questions is you can just get your colors, like blue and red. Red, we're gonna show where we have, like, let's say negative x values. This is where we have negative x values. And then red, we're gonna show where we have negative y values. You see, so this is the x-axis, right? It's just the x-axis here. So on the x-axis, we have negative x values to the left. And then we have here our y-axis, right? So we have, remember, this is representing y values of f. So y values of f, they are negative over here, and they are negative over there. So we're done with where things are negative. Let's do blue now. We want to look for where we have positive x values and where we have positive y values. So positive y values, we have that up here all the way to the other side. And then positive x values, we have that from here all the way there. You see, without the 0, obviously. Same with negative. We have it from here going to the left, but without the 0. So if you want, we could maybe even be psychoanalytic about it, and we can maybe even just remove the 0 there, because we're trying to say everything just above the 0, everything just below the 0. But anyway, so with this being done, now when you answer your question, what you do is you ask yourself, okay, fine, where do we have positive x values while having negative y values? Now, if you look at our image, that is only happening from this place going to the right side. So if you look at what we have over here, right, from this place here going to the right side, that's the place where we have positive x values while we have negative y values of f, because you have the negative y values here, you have the positive x values there. So for your answer, you're going to say x is bigger than 6, because we're starting from this x value of 6 going onwards to infinity. We're saying bigger than 6 because specifically at 6, there is a y value of 0 there, and that won't work out because 0 times anything will give us a 0, of which 0 is not smaller than 0. So here we're saying x is bigger than 6. Now that's the first portion of our answer that qualifies. The other portion that qualifies is where we have negative x values while having positive y values. And we can already see that's happening from here. We have our negative x values are starting from here. So we have negative x values here all the way until here. Between this place and this place, this is the only place where we have these negative x values while having these positive y values over there. You see, because that's what we're looking for. We're looking for negative x values while we have positive y values of f. So here we have positive y values of f, while having negative x values there. So that's from -2 up until 0. So the second portion of our answer, we have to say x is bigger than -2, but then those same x values, they are smaller than 0. You see? Yeah. So these kinds of questions, I mean, they will always be there in whatever paper you go through. So the thing is, over time, you would have then gotten to a point where you would then be able to decide whether or not they are your cup of tea. Because, for example, if you look at the three prelim papers that I've gone through so far, there you'll always definitely get the kinds of questions like the one we have just spoken about now, like guaranteed. Something like this, you see, for which values of x is f of x below g of x. And you see, we did the same thing. You're coloring g, where is it below the graph of, you're coloring f here, where is f having y values that are smaller than the y values of g? And then we answered the question. That's definitely something we know they would always ask. With any other question paper, like for example, the Gauteng one that has been done, and also the what you may call the Northwest paper that has been done, you're bound to bump into these kinds of questions, as we mentioned also, because it's like it's just standard procedure for them to ask those kinds of questions. So if we're looking at something like this paper also, right? If we're looking at, say, the functions questions, like some of them, guaranteed we're gonna get what we were talking about just now. See, so if I go to, say, maybe question 5, maybe, I think, I don't know what it would be, but it's definitely going to be like somewhere specific. Maybe let's say question number 4 or something, or whatever. So let's see here, question 4.6. Here again, you see, for which values of x is this expression times this expression smaller or bigger than 0. So you can see, if over time you've gone through it like 3 or 4 times and it's like, okay, it's not my cup of tea, it puts your mind at ease, because you now know where to save your marks and you now know where to save your time. Because in an exam out of 150, you don't want to go in there naive to think that, oh, those 150 marks is something you can get a piece of. So when you know exactly what you can get of, you are able to now allocate time to it consciously.
Strongest suits, yeah.
Yeah, that way you'll at least be able to finish your exam. And then you will know also, walking into the exam, how much are you expecting. The only way you will know how much you're expecting is if you've gone through multiple papers and you've marked it and you've tallied the marks and you've seen, okay, consistently I'm getting this mark. And then from there, if you want to bump it up a bit, then you're able to see, okay, I can bump it up with some of these questions, because they may not be understandable, but they seem like out of the rest of the questions, they are the ones you can at least maybe put a bet on. Otherwise, it's going to be a problem. So does that make sense?
It makes perfect sense.
Yeah. So this last question here, right? I just want to give you an idea of what you will bump into as you're going through past papers, so that you can then decide, as we said, what we need to decide on. So they're talking about R. They say the coordinates of R with a punctuation mark there. They said it is the image of the original R on P. Now they said if the equation of P is this, we should determine the coordinates of this new R, which is the image of the original R on the graph of P, if the equation of P is equal to this equation. So all they are saying is R here is here. Its coordinate, as we know, is just x is 0, y is 12. So all they are saying is you now have a new equation. This equation is P of x. P of x is equal to minus f of x minus 12 minus 2. So all they're trying to tell you is, right, is that something has happened to the equation of f. The equation of f, two things have happened. So this here shows you it has been moved 2 units to the right. This here means it has been flipped about the x-axis. The reason why this is saying it has been flipped about the x-axis is because if you look at a Cartesian plane, if there's an x-axis here, on top of the x-axis you have positive y values. Under the x-axis you have negative y values. So if your graph is flipped about the x-axis, your y values are going to change from positive to negative or vice versa. So that's what we need to do to the coordinate of r. The coordinate of r, the original coordinate of r, we said it is 0 and 12. So all we have to do to it is we have to move it 2 units to the right. So this is going to become a +2. And then we have to flip it over the x-axis. So if you look at it visually, if you're going to move your graph, your point, two things are happening to the point, right? We said you're going to move it 2 units to the right. So it's going to move 1, 2. So let's do it actually nicely. 1, 2. This is where the new x value is going to be. After moving it 2 units to the right, this is telling us it needs to be flipped about the x-axis. So this is the x-axis, right? So you need to flip it so that it's like somewhere down here. Now, the way you do it is whatever this distance is with the x-axis, it's going to be the same distance going downwards. So that's what we need to be conscious of. So let me just move these answers for now. So these were the other answers for the other question. So you see, we're saying here this distance is like 12, right, away from the x-axis. So the new point of r has to be 12 downwards, which is like if there's a +12 here, the new point will be down here where it's going to be a -12. So the x value will be a 2, the y value will be a -12, because that's what has happened. It has been moved 2 units right, and it has been moved 12 units downward. So it has been flipped about the x-axis. So here, let's say flipped about x-axis. There we go. So you can see that's for 6.5, right? So let me just stop this here. Stop this one here.